Well, hello. Well, this is Kiss This, and I'm going to do a little show and tell here on the pick and place machine that I built. I built this over a year ago, but I'm just finally getting into using it a little bit. And I got tied up with another project, a tennis ball shooter for my daughter, and that kind of put this on the back burner for a little while. But I thought I'd do a little video and show and tell so that people can post and comment on what I've done wrong, how I might improve myself, and hopefully there's some things here that the community might gain from looking at. And I really appreciate all the posts and the videos and so forth that everybody's done, especially on Openpnp. And without those, why, this would have been much more difficult. The basis for this is I found a bill of materials from what's name is written as Michael PNP. Thank you, sir. And I pretty much ordered everything on that bill of materials. And then there was MGRL on YouTube that posted, and I believe they posted some step files. So those are helpful. I imported them into Fusion 360, but did not really copy them exactly. But they were a great reference, and it gave me an idea of where I wanted to go with it. So as we look down on this, we'll just start. See if I can get her in view there. I mean, the basic, we'll start out with the x-axis, which is pretty straightforward, using the standard timing belts and pulleys. As you'll notice that where a lot of guys have plastic, I'm fortunate enough to have a mill, and I machined out aluminum 3mm supports on the ends. And over here, where we kind of have this transition between our trays, our wire trays. I've made a little channel here to help support it. A little feeder in the back here out of 3D plastic on the 3D printer that kind of brings the wires up into it. Makes it a little neater. And the NEMA 17 motor here. I like the design where the belts goes down inside the extrusion, makes it nice and clean, and that works really well. I like that. That's a neat feature. And also, I have a limit switches, a series of micro switches that limit the X and Y axes. I do not have that on the Z, but on the X and Y axes, if I go all the way to the one end, it'll disconnect power. And that's pretty typical of CNC machines. If we go over here on the left side here, you'll see here is a little sensor. This is a Honeywell, I think it's an SS441 Hall effect sensor, and I have a magnet on the carriage here, and that's what I use for zeroing out the rail. And I've got a Hall effect sensor on X, Y, and Z. I get 0.01, 0.015 millimeter repeatability, which I'm happy with, and it's much better than using, at least it was my experience so far, in visual homing. If when I do a fiducial on a board, if I do it 10 times in a row, I'll vary 0.03 millimeters. So that could be in the way my pipeline is. I'm not sure, but anyway, I'm very happy with the magnetic sensors for doing the homing. On the over here on the, if we get onto into the y-axis, homing sensor is here, limit switches on the other side. The y-axis being a little heavier, of course, because it's moving the Z stepper and the C1, C2 steppers, and of course this whole carriage. So I chose to put in a NEMA 23 motor in the back here, with a bar across and to transfer the power. And you'll notice, I'll show you later on the other side, I've got a separate stepper controller to power that. Instead of using the smoothie board stepper drivers, I'm using a separate one to handle the larger motor. Okay, let's slide her back here. Let's get around to the other side. All right. Well, looking at the the meat of the whole thing, of course, is this Z-axis here. Let's see if we can zoom down here a little smoother than if I can. Okay. The Z-axis kind of went through, I can't tell you how many iterations before I got it where I wanted it. And I think I got it where I want it. The two NEMA 8s motors here are driven through 3mm line, and I'll tell why that is a little bit. On the left side, my left nozzle is just a mechanical change. On the right side, I have an automatic changing holder, and I had seen, I think it was Belt's Technique up in Canada, machined a really nice one. I don't know if you can see it here, and I ordered one, and I got antsy waiting for it, and I ended up making my own, and that's what's on there now. And the advantage to what I like about mine is I made it. It wasn't easy to do, but I made it the exact same height as the manual one. So both of these sit level and appear the same. I only intend on having a change on the right nozzle, and that can go over and I can pick up one of my 4 different heads in my holder over there. Okay. The rails here, I think I bought these from Mitsumi. I think they're maybe 10mm rails. They work good. All the other rails here are cheap, bang good rails, and they work fine. I have no complaints. So whatever, I've used linear rails fairly often, and for what this is and the low loading that's on them, I'm quite happy with them. So for whatever that's worth, if you're trying to save $1 or $2. Up on the top of the head, let's see if we can get up in here. There is a little circuit board, and behind that circuit board is mounted 2 MPX 5100 pressure sensors, and that I'm going to use to detect whether or not I picked a component or not. But an interesting thing, since I had that mounted on here, and it goes to the input of the smoothie board on, I think, the 3rd and the 4th temp sensor inputs, I was able to do some experimenting to see how fast the vacuum rose after I opened the valve. So I can look at, I'm sensing the pressure right here, and at the end of this whole line, all the way back over here where the valve is. And I found out that at first I used 6mm line, and the 6mm line is pretty stiff. And of course, with it being that stiff, why the motor, these little NEMA 8s couldn't turn it. Okay, so I machined this kind of stuff with an O-ring and put it on and tried it for a while. It works, but I don't know. There's just something about it. It leaked a little more than I liked. I mean, you're sucking up through the bearings, on the motor. Plus these heads don't seal perfect, and I really wasn't happy with that. So after doing some testing, I found out that this brought the vacuum pressure at this point twice as fast as if I had 6mm line. And I'll post a couple little pictures I did one day testing it out. I used a trigger off the solenoid to trigger my scope, and then I looked at the pressure to see it come up, and the little line would bring it up to max pressure in maybe 50 milliseconds, where if I had 6mm line, it's got to suck all that air out of 6mm. Why it took up sometimes 300 milliseconds or 150 milliseconds. I think it was about 150. So at least twice as long, almost 3 times as long, to get that vacuum at that point. So anyway, these little LEDs I got up here, I don't know, I had a couple extra op amps on the board, so I kind of have them set with a pot. They can, when you have vacuum, they come on. I don't think that was worth the effort. But anyway, you can't see it very well, but underneath here there is a down-looking camera, which is just one of the recommended USB camera. I don't remember the number of it. And I made a little piece here that the camera mounts on, and I ended up, this is just a test piece I made out of plastic here, but I did turn this out of, made this out of aluminum, and put the tilt on here so that the LEDs point at the surface here. This is about 15 millimeters above this plate. 3 millimeter plate, tapped and drilled on at 50 millimeters over the whole board. If I did it again, I'd do 20 millimeters because 50's too coarse. But anyway, the camera looks down. The heat sink, I can leave the downlights on all the time, and that's not a problem. Okay, let's get go around here to the side and see what we can see. All right. Alrighty. I did not want to put anything underneath here. I might put my accumulator can, you'll see in a minute, underneath here, but I didn't want anything under here because it's just hard to get to, you know. So I mounted everything on the side as we go around the machine. And here is an emergency disconnect. There's my arming switch to arm the relay for the automatic disconnect if we hit a micro switch, and power in and out circuit breakers. This is the DM542T that runs the NEMA 23 stepper. I've got 17s on 17 here on X, 17 on Z, and then the two NEMA 8s here, 23 here. The smoothie board, you can see over here is just the hodgepodge of all the valves and stuff that you gotta you have to wire all up, and as clumsy as I am, but there's a couple little extra things here I did. I made a regulator board so that the pumps come on, bring it up to pressure and vacuum, and then they shut off. And there's levels. I have a couple of pots here, which I can set the levels on as to what the maximum and the minimum pressure is on pressure and vacuum levels are. And then also with an accumulator, and this is, of course, as you can see, this is about, I think I wrote 600 milliliters. And it is many, many, many times the volume that's in this small line. So when you open the valve, it immediately pulls that line all the way down, and of course it averages the vacuum out with whatever's in here, whatever I've got this at. So it pulls it to maximum to the value very, very quickly. Works really well. So I'm happy with that. This eventually I'm going to stick underneath there, but I've been lazy at this point. Okay. Here, I don't know if I mentioned, but this is just a DC regulator. A couple LM317s that I can change the voltage, go into the LEDs to adjust the brightness. Okay. Well, that's the gist of that. All of this stuff that's mounted here on the board is kind of, I'm just starting out here, so I've got some ESP32 modules that my 506 can pick up and set down, which I'm happy with that. And all of our strip line, almost everything I'm going to do is strip line. I'll probably build some kind of a feeder, like a bump feeder, for, later on, mainly for fun. I don't, for what I do, I probably won't use it very often. But anywho, one thing I goofed is when I made this, I left out the little clips that some people have to hold that in position. So before I start, I go over and make sure they're pushed all the way, and then I can change nozzles without any problem. Let's see here. We talked about, I don't know if we talked much about the up camera. The up camera is mounted on a little frame that I've adjusted to get it level, and this is a little diffuser, and the LEDs here are oriented such that the light The idea being the light is right at the level where when these are neutral. And I figured that you save time. If I see some people go over and they drop it all the way down to get it in focus, and they check its position, then they lift it up. I can understand if you don't have this thing all lined up, that's the most accurate way to do it, is check its position at its level that it's placing it on the board. My hopes is I've got everything lined up perfectly, and that won't make any difference, or not a significant difference. We'll see. You know, I have not done. I did one other little board, and this board is my ESP32 board. And what is it? 1 by 3 or so, 1 by 3.5 inches. So we'll see. Well, that's about the gist of this until we. I made a little board holder here, which I haven't decided if I totally like it or not. But anyway, for make it easy to change the boards. Well, let's see if I can't get a different camera geared up here, maybe, and maybe do a split screen and move it around a little bit. You know, I had mentioned that I had bad luck with these, but I really didn't expound too much on the way to solve the problem. But these I found were terrible. I finally ended up making a bunch of these plates and a bunch of angle plates, and using 5mm bolts and T-nuts. I'm not sure how long that bolt is. It's looks like a 6mm length 5mm bolt hex nut. And you know, when I first got them, I did not like them, but after a while you learn how to push and turn, and they'll go in there and latch very well, and it makes for assembly nice and fast. And I think any builder would know this hint, but of course, cut a bunch of blocks the exact height you want, and I put that under the whole frame, put these plates on, and why, within an hour I had a nice, perfectly flat, square frame, and I haven't touched it since then. So anyway, also, any of my sensors that mount on this rail, I can move them back to adjust them, and I just have I printed a little, a little plastic typical T-nut that fits behind here, and that's tapped for probably a 3mm screw, and it makes it easy to mount all your sensors. And then stuffing the wires in here makes a nice clean install. And I printed up these little gray strips that are about 6mm wide, and you can press them in there and they cover the wires up. So anyway, hope that's worth something. Okay, let's arm the machine. Let's do a reset here. We'll come up and reset the head. Okay. Turn off the, well, we'll leave it on. I was going to turn off the down cam light, but we'll leave it. Okay. Let's, well, let's play here. I'm going to go up to a feeder here. We've got to reinitialize it, so we'll come down here, pick that component, put the camera over it. Okay, and let's do an auto setup on this, since I just put, we'll call that the first guy. Okay. And we'll call that the second guy. I always come down and look and see where my camera came out. Now, that's okay. A little bit to the left. I don't know if that's as good as it can get or not. This is all new to me, but we're going to leave it that way. We're set up to use vision both in finding that, and when we come over to the part, we've also got vision to correct for it when we pick it up. Okay. Now we're going to go put it on on a circuit board. It's not really a circuit board. It's just a strip that I've set up here and pretending it's a circuit board. So let's go down. Oops, let's go here. Okay, and there is the little strip I've set up. We're going to call that a board. So we're going to go down here and we're going to call. Let's see if we can get pretty accurate here. Okay, we're going to call that the board position right there. Okay. Now, if you'll see here, I've already put 3 of those components in, and they're the board's 0 position and the first component's the same. That wouldn't normally be that way, but we're going to do it that way. And then I set the second component 4 millimeters up, and then the next one 8. Okay, so that is our board. Okay, that's the component. The feeder's been initialized. I didn't hit ply. I don't know if that's for the pipeline or not. Anyway, here we go. Let's just go see if we can run this, and it should take the component off the strip and place it on this strip, if it's working right. Well, that's pretty good. They're all in the box, but they're all tilted a little bit. If that was on a board with paste, I think those would be perfect. So I'm quite happy with that. Let's see. Let's get rid of this and load a board that I'm gonna run here. I hope when I get all the components loaded up on it. Okay. That's this board here. So let's go down and go to that board. I haven't set my, I don't really have my up-down camera lights set right. So let's see, up, down light on. Okay. I've got a script, but I've also got stuff in the Boolean for those lights that is goofing the strip up, I think. So let's come over here. Here's the board. Okay, so we got to give it, let it know where we think board 0 is, and then we'll use there's 3 fiducials on the board, and we'll use those to more accurately, find the board position. So we'll hit the fiducial checker here. Oh, I probably don't. Let's see here. They're not going to do that. Here's fiducials. We'll select those. And now it should unable to locate. Well, maybe I didn't tell it where the board was very well. Yeah. Figure it out here. All right. I might have not clicked on the right icon. Let's go up here. Okay, there. We're going to call that the board position. And now let's do a fiducial check. Yeah, there we go. The first one, second one, and we come down to the third one. And now it'll go to what it considers as board 0, as defined by that board file. Now, if we look up here, it says 42, 542, and 146, 736. And if we write those down, for make a little point here, 42, 542, and 146, 736. Okay. Now let's do it again and see what our answer is. And I have found that my Honeywell sensor reset is better than, it's about 0.012 or so consistently. Now here, 42, 534, okay, and 146, 710. So we went 0.026 difference on Y, and 534, 0.008, real good on X. So now I can do consistently better than that. As far as finding homing position, I'm comparing this to whether you used visual homing. So in my case, with my machine, visual homing wouldn't do me any good. Okay, well, let's I'm gonna place a ESP32W rover module on this board, and we're going to go over and pick up my 506 head, and let's see how this works. Okay, well, let's go. We're going to look at the feeders, reset that. We'll go here and reference nozzle 2. Let's load the 506 nozzle. Let's go over into that. Okay. And now we can go over to our job, and we've selected to put on that component, and we're going to check fiducials. So we'll do that first. Reset that. Okay. Doing its fiducial check. That wasn't bad. I need to release I need to have pressure on it, and it wouldn't have done that little blip up, but that's pretty good. Well, now I got a machine that I think works fairly well. Now I just have to figure out how to use it, and that'll probably take me a while. But I'm happy with it. I hope you enjoyed it. I would appreciate any comments, positive or negative. Things that don't see to be a problem that might be, and maybe any advice you could give on how to make it do a better job. So once again, thanks for listening, and we'll talk to you later. Cheers.